We're back with our B7 build series, and our track is back to off-road with a brand new layout. We just finished with our first race and won, and now we're anxious to get back on the track. But our tires are smoked, so we're gonna put on a fresh set of fuzz bites front and rear, hit the track, and figure out where our laps are.
16-4.
So after some good running on this new layout, which looks pretty simple, but it's pretty dang challenging, we've got a 15.9 fast lap. But we can't do it consistently, and we're kind of crashing a lot. Now in the last video in part 2, it was mentioned that you need to replace all 4 tires, even if you only need fronts, just to keep the traction levels balanced. But somebody commented, that shouldn't be the case at all, and you should be able to put brand new fronts on worn rears. So let's test it.
16 flat.
So it is noticeable. You can feel the rear end of the car kind of sliding around. The front end's driving the car around. In some of these 180s, when you let off the gas and turn, the rear end just slides. It's kind of feels maybe a little bit fast. Our fastest lap was a 16 flat, and I think we did a few of them. So brand new fronts on worn rears, that's okay. Next, we bought a Hobbywing program box. It's the multifunction LCD Program Box Pro, and we probably should have connected this to the ESC immediately. We've just been using it in its factory default settings, which has been working okay. But we don't know what's going on inside of the ESC or how it's programmed, so let's crack this open and connect it to our car.
So we gotta unplug the fan.
So it turns out the ESC was in an on-road profile. We switched it in the mode settings, putting it into off-road, and then you go into your parameters to make all the different ESC adjustments you want. Now the program box manual does not explain what all the program settings are or how they affect your ESC, but the ESC manual will. So if you have questions, you can go check that out. Now there's a lot of settings to go through in here. We only made a few changes. We changed our profile to be into off-road, and then we bumped up our BEC voltage to HV. We would like to mess with the throttle frequency to lower that to 2 or 4K. That's supposed to make the car punchier and recommended for stock buggy. Ours is set at 12K and it feels pretty dang good. We're not going to change it for now. We'd also like to mess with the brake. I want a little bit more brake force. That'd feel great. And then maybe even some drag brake. But knowing we can take the program box to the track and make these adjustments easily one by one to test them, seems like the better way to go than making all these adjustments now. Now something really cool is the data logging with the program box, like our motor RPM, which will come in handy later when we make some adjustments to our motor. But first, let's trim some fat. And we're gonna do it using the Exotech B7 Slipper Eliminator, or lock spur mount as they call it. And this includes everything except the spur gear. And as the manual shows here, there's different screw sizes depending on which spur gear you use. And we've actually picked up a Revolution Design Ultra spur gear. We've got the Kimbrough spur gear and then the Exotech Flight spur gear. And interestingly, the Exotech is the heaviest at 3.5 grams. The Kimbrough is 3 grams, and the Revolution Design is the lightest at 2.7 grams. And that's what we're going to go with. Now to try to save a little bit more weight on top of this, we're using titanium screws, 3x6 millimeter button heads, and these save about a half a gram. The steel screws are 1.4 grams, the tie screws are 0.8. So we've almost saved a gram extra by just using the Revolution spur gear and then the tie screws with it. Now in the end, the slipper assembly is 23.6 grams that we removed, and then the slipper eliminator is 7.2 that we added. So we've saved 16.5 grams, but we're not done yet. So we topped this off by adding on the JK Products plastic pinion gear, which requires an 050 hex driver for the set screw, but it's totally worth it because this dropped another 1.3 grams of weight compared to the aluminum pinion that we were using. Now these pinions are only for stock racing, or they probably will break, but we dropped almost 18 grams of rotational weight from our transmission in total, which is pretty massive to remove from that rotating part of the car. But wait, there's more. Now, one of you guys in the last video recommended the Wits Racing ceramic bearings and the aluminum screws. The ceramic bearings, of course, are meant to lower the rolling resistance, and then the aluminum screws are supposed to do something with magnetic field. They say on the product page that it reduces the magnetic drag and helps boost RPMs. Now, I've never upgraded a brushless motor before, but we got those parts for our motor, and they sound pretty interesting, and if anything, the aluminum screws dropped 3.5 grams over the steel screws. Now, disassembling the motor is pretty easy. It's just super important to keep track of all the shims on the rotor, and they're gonna be on each end. Pulling the bearings out is a bit more challenging, and we picked up this McLaren motor bearing tool to help us out. And I imagine this tool is actually made for McLaren motors because we did have some issues, and it's only for 540 sized motors as well. Now, popping out the front end bell bearing was a piece of cake with the tool, and installing the ceramic bearing in that front end bell was equally as easy, but the rear end bell was another story because the sensor port is oriented towards the tool when removing the bearing, and it wasn't going to work. The tool was going to hit that sensor port. So instead, we had to put the rear end bell in a vise. We gave it a little heat from a heat gun, but not too much. You can fry the sensor board, so you got to be careful. And then we just hammered out the bearing, and it came out pretty easily. This was the most challenging part, but when you install the ceramic bearing in that rear end bell, the tool actually is flipped, so it's going the other way, and the sensor board does not hit the tool, and the bearing popped right in. So, our motor is now upgraded, our transmission is now lighter, and our overall car weight is sitting at 1455 grams, which is 22 grams lighter than when we weighed it in the previous video, which is underweight, but that's easy to remedy, and we've got a lot of flexibility in how we want to do it. So out on the track, the difference is drastic. The car has just immediate punch and it spools up super fast. We later tested temps and they were nice and cool, and we have room to gear up if we wanted to. How much of a difference did the motor upgrades versus the transmission upgrades make is unclear, but the car is drastically punchier. Now there is an issue though. When taking off from a standstill or sometimes landing hard from a jump and then accelerating, there's a little bit of a lag, a little bit of delay, and I thought maybe we messed up the sensor wire when we took out the motor. So we tried other sensor wires, we tried running without the sensor wire, we tried calibrating the ESC, and nothing fixed the issue. We tried a different motor and that resolved it, and it turns out we messed up the sensor board in our Wits motor changing the ceramic bearings. And this was verified when we put the Hobbywing program box on the ESC. The RPM data out of the motor was 47,000, where previously it was 25,000. So the sensor board's not working right, it's not transferring accurate data, and this is massively disappointing that we messed this up. We've emailed Wits Racing, we haven't heard back, but when we do, probably in the next video, we'll let you guys know what they say. So kind of a fail, but the transmission upgrades were still definitely a success, dropping weight, delivering more punch, keeping the motor pretty cool, and giving us more efficiency and room to gear up. So in the meantime, we still have another motor. We've got a loaner motor we're gonna use, and we're gonna end this video by trying to get just a little bit more steering out of our car. And interestingly, one of you guys suggested in the last video to try some four-wheel drive fronts, fuzz bites, and it turns out the front fuzz bite is made in a two-wheel drive slim, a two-wheel drive wide, and a four-wheel drive. And the two-wheel drive wide is the same diameter as the slim, but notice how much taller these four-wheel drives are. So the slim fronts are really good. The only thing I'd like is a more initial turn in. So these wide fronts are aggressive.
5-6.
Might need a little bit of dual rate. Goes up on 3 wheels, it just kind of hooks on the carpet. These four-wheel drive fronts are edgy. They're bigger, they're thicker, they've got more cushion.
And you can feel them kind of help with the landings, but they're just super edgy. Traction roll a few times.
So we've got a few other ideas to get more steering by adding weight to the front, but first, let's put the car on the corner weight scale and see where our weights are. Now, something strange here is it's showing the right side is heavier, but the left side should be heavier. When you look at the chassis, the ESC is offset to the left, the motor is offset to the left, the fan is on the left side. Something's not right here. So I checked the chassis, because I've heard that chassis bend easily on carpet, and ours is bent up, and it seems like it's tweaked the front end, so it's tweaking a little bit to the right, and when you lift up the front end, that right tire is staying down a little bit lower. Even though we measured the shocks, they're the exact same length. So we're just going to keep using it for now. I actually didn't even notice on the track. It must be pretty subtle, or I'm kind of just a big noob. But what we're going to try is moving the battery forward, because currently the battery is in the notch 4 position, so we're going to move it all the way to the front. I think it's referred to as notch 5. So here on the right side, that's in notch 5, and that's forward maybe 4 or 5 millimeters compared to the left side. Now back on the corner weight scale, this increased our front weight by only 3 grams.
I don't know if I can really tell a difference. Maybe a little bit. It's very subtle.
Now driving on the track, we were using our original slim fuzz bites, which are pretty worn.
Wow. And now you see why the chassis is bent.
Now the second idea for a little bit more front end is to add the 16-gram steel servo plate, and installing this is pretty dang easy. We just have to pop off the front bumper, peel back the chassis protector, take the servo screws out from underneath the chassis to move it out of the way, and then we use a little Loctite on the plate screws to attach it. Now back on the corner weight scale, as expected, the front end weight increased. It went from 636 to 651, and the front weight bias jumped from 43 to 44% too. Now these scales aren't perfect. On the regular scale, the overall weight is 1478 grams, which is 4 grams over the roar limit. So let's try it on the track.
So the extra weight is definitely noticeable, although it's pretty subtle with bald tires. But it makes bald tires a whole lot more usable than they were before.
So that's all we got for you guys. We trimmed some fat, we gained some speed, we picked up more steering, and we earned some fails too, bending our chassis and ruining our motor, feeling extremely disappointed after going from winning our first race in part 2 to feeling like a noob in part 3. But I suppose that's the ups and downs of racing. We're still learning a lot about our car, and we're having fun doing it. So for next time, we need a new chassis. So should we buy the -4mm short chassis? Drop us a comment down below. Otherwise, go check out the links to everything we talked about in this video down below. I'm Brett from AMain Hobbies, and thanks for watching.
Ouch, ouch, ouch.